Alright, so now we're going to do examples of finding the critical points and determining using the d-test if I've got max, mins, or saddle points. Alright, give both the relative extrema and the function value that it occurs at. So if I find a maximum, I'm going to plug it in and find the maximum function value. Alright, so for our first example here, maybe if I get my thing to cooperate. Alright, so we've got our first example here. This is a simple case, so we'll set it up, find our critical values first. So find the criticals first. First derivative with respect to x, 24x minus 52. First derivative with respect to y, 60y minus 90, set it equal to 0. So this is the solve for x, solve for y case. Alright, so I'm going to leave it exact, don't round. It's exactly either 52 over 24 or reduce it to 13 over 6. Alright, so again, you have a fraction key on the calculator. Alright, it's exactly 13 over 6 is where the critical moment is. Alright, now solve this one. Same thing. It's exactly at y 3/2. So my critical value is at the point 16 thirds, or not 16 thirds, I flipped my 6 and my 3, 13 sixths, and 3/2. Alright, now I want to figure out, well, is that critical value a maximum, a minimum, or a saddle point? And so I need my D formula. Remember, the D formula is the second derivative with respect to x times the second derivative with respect to y minus a mixed derivative, don't forget to square it. And I'm just going to find these. In a simple case like this, my second derivatives are actually all numbers. All right, and so I'm just going to find them and plug them in the right spots in my formula. So the second derivative with respect to x, I have to look here. All right, there's my derivative with respect to x. Take it again with respect to x. Well, it's 24, right? The derivative of this is 24. All right, the second derivative with respect to y, well, I go over here and I look. I take its derivative with respect to y. Well, the only part is 60y. Its derivative is 60. And then the mixed derivative, well, the mixed derivative is 0, right? Because there aren't any mixed variables, right? If I took the derivative of this with respect to y, there aren't any y's, so it zeroes away. Same thing as this one. Take the derivative of this one with respect to x. There are no x's, it zeroes away. And so this is just 24 times 60. Well, that's going to come out positive. So yes, it's an extrema. All right, then I look at my second derivative with respect to x to see which one it is. Second derivative with respect to x was that 24. Well, it's also positive, which means it's concave up. And so that means this is a relative minimum at this point. And then to find what it is, well, I plug that point, those values, back into my original function. So I go back up, I put f instead of c. Alright, so I go back up here, plug in my 13 over 6 for x, and my 3 over 2 for y. When that value that comes out, well, that will be my minimum. And I'm assuming since this is a c function, it's probably cost. Alright, so that's probably my minimum cost. So when I plug it in, again, make sure you're careful. It's really easy to mistype, especially with the fractions. Alright, so when I plug it in, I get 476.17. Alright, you might want to double check me on that. And so that's the value that I get. Alright, so that would be the minimum when I plug in my critical point. And it's a minimum because my test said it was. Alright, the next example. P of xy. So I'm assuming this is a profit, so I'm going to guess it might come out as a maximum. We'll see. Alright, find my critical points first. So take my first derivative, set them equal to 0. So my first derivative with respect to x, negative 1200x, zeros away, positive 1200y, minus 300, set it equal to 0. My derivative with respect to y, negative 2400y, 1200x plus 4500. Alright, this is a linear case, which means you can solve by substitution or the matrix method. I prefer the matrix method, and I went over how to do that in the last set of notes, so I'm just going to write out what I'd plug into my calculator. Alright, first thing you have to do, it's the linear case, so you have to rewrite them in the form x value first, y value second, constant moved over to the other side. Alright, that's the way it has to go into the matrix key of the calculator. And so when I rewrite this, I've got to add the 300 to the other side. Alright, so negative 1200x comes first, positive 1200y equal my positive 300. Alright, the second one, I've got to move the 4500 over, so it's going to become a negative 4500 when I move it over. X value first, so positive 1200 for x, negative 2400 for the y, set equal to the negative 4500. And make sure you're careful. When I move stuff around, my negative values change. Alright, so make sure you're careful. You write the x value first, the y value second, set equal to the constant where you've moved it over. Alright, now I'm ready to plug it into the matrix, but I have to plug it in this form. Alright, so again, in order, x value first, y value second, constant. And watch out, there's a lot of 1200s. And make sure you're careful with your negatives. Really easy, and I forgot my negative on my 4500. It's really easy to mistype something, so just kind of do a double check when you plug it into your calculator. Alright, so again, 2 by 3 is what you're plugging in, so that goes in your calculator. Row reduce, remember you have to scroll off your page under the math key in your matrix button. Go down to the RR, the double R, not the single R, RREF. And then it should spit out the following matrix. Remember, the first number is my x value, the second number is my y value. Alright, so my critical value is the point 3.25 and 3.5. Alright, well now I want to know, is it a maximum point, minimum point, or saddle point? And so I have to test using my d-test. Alright, which actually I need my first derivative. So I'm going to kind of clean these up a little bit, because I'm going to look there. Alright, I'm actually going to erase this so I can look there to find my second derivative. So give me a second while I give myself a little more room to do my second derivative. Alright, so my first derivatives. So I need my second derivative with respect to x, my second derivative with respect to y, and my mixed derivative. Alright, they should all come out numbers. Whenever it's the linear case, again, they're all going to come out single number values. So if I'm looking at my x function, second derivative with respect to x is negative 1200. With respect to x, then y, positive 1200. And then with respect to y twice, negative 2400. Alright, then I plug them into my d formula. I'm going to write it out. Alright, second derivative with respect to x times the second derivative with respect to y minus my mixed derivative. But don't forget, it's the mixed derivative squared. And so again, these are just numbers when it's this case. Right? Because I just got numbers when I took my second derivative. Just to make sure I go in the right spot. Negative 1200 goes into the xx spot, 2400 goes into the yy, and positive 1200. And then multiply it out. And it comes out to a fairly large number. Alright. Which is a big positive number. And so yes, it's an extrema. I just don't know which one it is, meaning it's not a saddle point. It's either a max or a min. And so I go check out my second derivatives. Well, there they are. P of xx is negative. And so that means it's concave down. Well, if it's concave down, this finds a relative maximum. Alright, then I plug that value back into my original function to figure out what that maximum is. Alright, so 3.25 goes in for x, 3.5 goes in for y. So again, going back up here, and plugging my critical value into it. So going back up to the original and plugging in 3.25 for x, 3.5 for y, and just make sure you're careful. There's a lot of big numbers and a lot of zeros. It's really easy to mistype something. And you should always double check my answer, make sure I typed it in right. So I typed in and it came out $3,787.50 if it were a profit case. Alright, the next example. So we did one where it was just straightforward. This one required the matrix. So I'm going to assume that the next one is probably a substitution case. And it is. As soon as I see those cubes, I know I'm going to have to use my substitution rule. Alright, find my first derivatives to get to my critical value. So my first derivative with respect to x was 3x squared minus 150y. First derivative with respect to y. Alright, so I'm going to guess that there's some symmetry involved here. So since I get the same thing with opposites in terms of x and y, I'm probably going to get out points where my x and y values are the same. Right? Doesn't matter which equation I start with. Right? Can pick either one. Doesn't matter which variable I pick because they're both about the same. They actually are exactly the same. Alright, so I'm going to pick this equation and I'm going to solve for y. Alright, I could have picked that one and solved for x and it would pan out the same way. Alright, so solve for y. I'm going to add my 150y to the other side. So I get 3x squared equals 150y. Divide by my 150. And so I'm going to reduce my fraction but leave it. 3 goes into 150, comes out 50, so x squared divided by 50 is what my y value is equal to. And don't round, leave it exact. And so that's what we're going to go up here and plug in for my y. And so when I plug it in, it goes in for y, so that expression is going to get squared and multiplied by 3. So it goes in just for the y part. Alright, so when I plug it in carefully, it's going to be 3 times that x squared divided by 50, still squared. Alright, the whole thing squared. Alright, and that should have been 150. So minus 150x, still equal to 0. Alright, well now I've got to square that. Make sure you're careful. That whole thing inside the parentheses gets squared. So the x squared is squared, and the 50 is squared. Alright, so it's going to be 3 times x to the 4th. 50 squared is 2500. Alright. I'm going to multiply through by the 2500 to get rid of it. I'm going to get rid of the fraction. So I'm going to take the whole thing, everything in here, and multiply it by 2500. That gets rid of my fraction. Remember, everything gets multiplied by it. So when I multiply here, it'll cancel that out. So I'm just going to be left with 3x to the 4th. Take 2500, multiply it by my 150. That's going to come out 375,000. Or 37,500 times x. Alright, now I'm going to solve by factoring. I can factor out an x and a 3. I believe a 3 does factor out. So I'm going to pull out a 3 and an x. When I do in the first term, I'm left with x cubed. Take that value and divide it by 3. I'm going to double check and make sure I've got the right number of zeros there for my... I think I'm missing a 0. 150 times 2500. Yeah, I am missing a 0 here. There should be an extra 0. So it is 375,000 times x. Alright, that's what I'm going to divide out by 3. So it comes out 125,000 equals 0. And then solve. First one, x equals 0. This one I have to do a little more work. My x cubed minus 125,000. Move the big number to the other side. And then take the cube root of it. The easiest way to take the cube root is to raise it to the 1/3 power. It's just easier to type it in your calculator that way. Or the cube root, if you got a cube root key in your calculator. If you do, it comes out 50. Alright, so I've got two values. x equals 0, x equals 50. Alright, so this function is going to have two criticals, and then I'm going to plug them in here to find my y value. Alright, so when x equals 0, well, y also equals 0, so there's one critical value. When x equals 50, well, y comes out 50 squared divided by 50, well, that's also 50. Alright, so I get two critical values. One's at 0, 0, and the other's at 50, 50. Alright, now I've got to check and see if they're max mins or neither. Alright, we're actually going to skip this problem. It's harder than I intended it to be, so I'm going to kind of skip that one. And so I'm going to do my testing over here. Alright, so the test to see what they are, well, I need my D formula. Alright, my D formula is the second derivative with respect to x times the second derivative with respect to y minus my mixed derivative, but that whole thing squared. Alright, so to go up here and I have to find my second derivative. So I'm going to go up here, I'm going to erase a spot to find my second derivatives, because I need my first derivatives to get to my second derivative. So I'm going to erase this here and do my second derivatives and then plug them in my formula. Alright, so second derivative with respect to x, my mixed derivative, and then my second derivative with respect to y. Alright, so my second derivative with respect to x is going to come out 6x, second derivative with respect to y, so going over here, 6y, and then my mixed derivative is negative 150. Alright, so there are my second derivatives. I'm going to go plug into my D formula. Alright, so 6x, 6y, and negative 150. Alright, so this one is going to be a formula. I'm going to have 6x times 6y minus a negative 150 squared. I am going to simplify that. 6 times 6 will give me 36xy minus my 150 squared. Comes out 22500. Alright, so there's my D formula. Alright, now I'm going to test my values. Alright, so the first one I'm going to test is 0, 0. Well, when I plug 0, 0 into this formula, this zeroes out. It's going to leave me with that really big negative number, that negative 22500. Alright, so as it comes out negative, makes that a saddle point. Alright, which means I'm done. It's neither a max nor a min, so I don't worry about it. It's just a saddle point, just a stopping point, but it doesn't give me a maximum value or a minimum value. Alright, now I'm going to test the 50-50. Alright, so I'm going to take my D formula, plug 50 for x and 50 for y. So I got to plug it in, so 36 times 50 or 50 squared minus that 225000. Alright, when he does, it comes out positive 6750. So it comes out positive, so that's yes, it's an extrema. Alright, well, which one is it? Well, now I have to check one of my partial derivative, or one of my second derivatives. So second derivative with respect to x, remember, was 6 times x. So 6 times 50. Well, that's going to be positive, so that means it's concave up. So that makes this is going to find a relative minimum. Right, since it's concave up. And then I find it. Alright, so we've got a relative minimum of, well, I take my original function and plug my 50s into it. So it's going to be 50 cubed plus 50 cubed minus 150 times 50, 50. And that comes out negative 125,000. And so my minimum is a big negative number. It should make sense then, it's a minimum. Right? Big negative number. My answer makes sense, right? That it's a minimum. We are going to skip there, so I am going to skip that problem number 14. It was harder than I intended it to be. The second derivatives are very difficult, and so don't worry about it. We're just going to throw it out. And we were able to do an example of each case, right? We did a matrix case, a substitution case, which is the last one. We found maximums, minimums, and saddle points, all right? So we did sort of one of each, so it covered everything. The next thing we're going to do is then applications. We're going to apply it, and so that'll be the next set of notes for 6.3. All right, so we're going to stop there.